Hello, welcome back. So let's do a short summary what we have done. So we have covered a lot, no? So tutorial one was the cylinder case. We visit many options, so hopefully now things are much clearer for you. So I invite you to revisit, try to reduce, solve many issues, boundary layer, refinement, and so on. So you have here all the standard practices to do a good mesh. Then in tutorial two, which was the airfoil, we address a few issues about regarding first boundary layer and then also the background mesh, how to control, get better control without skyrocketing the memory usage and the number of cells that we need to use. So I'll show you many tricks how to do boundary layer. One advice, you need to learn how to live with these small defects here in the trailing edge. In this case, it's not such a big deal. Also, when you do the meshing and everything, my advice, if you want to go into debugging, is you take all these tricks that I gave you as granted. Don't care about this, but also always save the log file, the snappyHexMesh log file, and just take your time, understand what is happening, where do you have the errors in case that you have errors. So here we have our log file. So you have all the steps here. Remember, step one will be the castellation. That one basically always works. It's rarely when you get errors there. All the refinement is done there. So you have surface refinement. Let me open here. System. So in this case will be folder one. I have the refine mesh, the Cartesian, and all the refinement is done here. Okay, so you read your surfaces, entities, whatever, and you can do refinement on a surface. You can do refinement in a region, and you can also capture feature edges. That in the airfoil case we didn't capture. We used the implicit option. That remember that you have it somewhere. I forgot here. You have implicit. Okay, recommended for 2D, but you can do it also in 3D. Location in mesh. You say where to put that point, and that's all. So these are the basic options. Nothing to change here. Okay. Careful here also maximum number of cells, but nothing fancy. So this dictionary comment, there are many options, but as you can see, it's not that intimidating. Then you move to snapping, and snapping also kind of is use the default values that are put recommended is you have some problems, and when you read the log file now, let's say time one, time two. Okay, when you read, no, let me time one. When you read the log file for the snapping, just look at the quality metrics. You see some problems. Now try to associate that. I don't want to go into details now about that where you have the auction, but it's just associate one of these auctions with some of the errors that you have here. Try to act on the mesh quality dictionaries, okay? And usually changing a parameter here and there, one option also increasing one option here can help you a lot. Now the last resource will be to modify the source code. Look at the source code. By the way, if I recall in the slides, there is one that I point out to the location of the, okay, let me see. Okay, I don't have a canal. Let me see where I put that. Okay, so will be lecture two. I think I point out to the location. Well, you have all the classes now, everything that deals with mesh quality control. Okay, where is that? Oh, lecture two. Okay, lecture three. So let's see if I have it somewhere, if I can bring it back. Okay, but this is advanced. I don't recommend you to do it. So here you have the location. Now you go all the mesh checks, all this stuff that is done, and there's you go deep and read it. You probably will understand a little better. Also, you have the source code for snappyHexMesh that is pointing to different classes and so on. So what I was saying that yeah, you have the snapping, usually it's okay, and then the tricky part is the boundary layer. I didn't go into detail about the auction, so also in this case you can play with the different auctions that you have here. My advice, the final layer thickness is the one that I like to use. You have also the Excel file that you can play around and you can see how to get the meshes. Everything are they are no standard geometrical progressions. Of these auction problems and other cases, we are going to play. I already showed modifying some of these auction. This one is you want to disable the checks. Probably this one, no, this one, or this one sometimes can help, not always. But later we're going to play with this auction, which is the other. These two are the other most important ones. The rest, I have to say, just use the default values. And while also you can get that snappyHexMesh, that tour guide, this one. And here it's a nice one, it's oldie, but it's still very valid. So you have some definitions if you don't want to go into the source code. What else? Then, well, the debug files. The next tutorial, now we're going to see this one, is just to save a whole bunch of intermediate files that you can use also for debugging, doing for the debugging. Mesh quality, use the default values or the values that you go into documentation, and they recommend values. I think it's the ones I'm using. I don't recall because it changes continuously and always update, but yeah, read the latest documentation and they give some default values. I know precisely from time to time what is my specific problem, what can I change. And that's it, okay? Nothing else. The blockMesh also, we're going to dedicate a video just to talk a little bit about blockMesh, but take it as a template here. You just give the box, put your geometry, and you're ready to go. And to end this one, remember that when you do the mesh, and I think I have it here. Yes, let me go here. Just a reminder that you can visualize the defaulty sets. So let me go here and let me do snappy XMesh. Let me read on a specific dictionary that will be system snappy XMesh BL. And then let me go refine. Okay, refine all layer and STL surface and go like this. 0.5, 1, 2, 3. Okay, so you have the photos there, and remember that you use check mesh latest. Latest time. Let me see the quality. Okay, still is well. You have some orthogonality is okay, but see here that you have the orthogonal cells, so you can go and write sets, if I would recall, and should write the sets in post-processing folder. I don't see post-processing. Write sets, right. So surfaces. And there you go. You have the post-processing, and here you have the BTK file with you are going to find, and you can visualize your mesh. By the way, in this case, I forgot to mention one thing that I didn't do the extrude mesh for the final mesh, so I still is 3D, so do the extrusion, and that's all, so I forgot to add that. Okay, so if I visualize here, look at that, still you have the mesh, so I need to do the extrude mesh to get the fully 3D, but it's not a problem. Everything works in the same way. I want to point out something that is here. You have an all figures. And this was OpenFOAM 10. And in OpenFOAM 10, look at that, by changing the mesh quality, this one, by disable these options, managed to get something like this. Now, in the new one, you don't get this behavior now. So I need to track now. I see that they did some modification. You get something closer to this, but it is not precisely to the trailing mesh, which is not bad. But then you have some expansion here that also you can see that you have it here now, that expansion. So I will track that one, but it's not something that I'm worried about. So yeah, that is everything concerning. So you have the most important standard practices. Next videos, now we will go into some very specific topics, issues, and if you have suggestions, please let me know on geometry, and if I have time, I can deal with that. So thank you for your attention, and see you next video, which is doing this geometry. Bye.